Then let's share. Okay, let's hide video panel. There we go. Okay, there we go. Okay, so Eduardo Del Angel, you're flagged today and tomorrow. So Delgado, and then tomorrow's Connolly. You're the only one today, so I don't think you're here. So there's that. The rest of y'all, whatever you do for flex, do it. Okay, so what I want to do today is go through some of this review for at least the next 10 minutes or so. So let's see here. So be ready. Yours might be scrambled up and stuff, but we'll get the idea here. So let's go to this review. All right, let's do a preview. All right. Okay, so let's just talk some concepts. So this test is very similar, guys. It's all concept based. So hopefully you did the 3 homeworks and got them. If you didn't get a good grade, you did them again to get a better grade and learn from it. And what you don't understand, you get in touch with me, okay? Which is going to be very limited since the test is tomorrow, guys. So let's have a look. Here's a quadratic, and we're going to label each part. So if we look at number 1, it's pointing to this vertical line that cuts the parabola in half. That is our axis of symmetry or line of symmetry. All right, 2 is pointing to these 2 dots here. These are on the x-axis. There are x-intercepts, our roots, our solutions, our zeros, and that's that option there. So pretty simple. All right, and then number 3 is pointing to that point there, which is the vertex. Bam, vertex time. All right, questions there? Now going on. So another thing you have to know is which form you're looking at. So here's the formulas for each form. You got intercept, standard, and vertex. So let's go through it. All right, so this one here that has a square, no parentheses, ABC order, that's standard form. All right, this one with the parentheses and a square, that's going to be vertex form. All right, and then if you have parentheses or no squares at all, that's intercept form. All right, questions on that? And then here you have like specific quadratics, and you can put them in whatever form. So again, here we are, we have a square, no parentheses, standard form all day long. Okay, here we have parentheses squared, vertex form. Okay, I'm gonna skip C, let's go to D. No parentheses at all, that's intercept form. All right, C I wanna talk about. Okay, so here we have a square, there's no parentheses, this one's standard form. Okay, it's technically both, standard and vertex form. All right, it's because it's x plus 0, right? But we don't write the 0, so the square goes to the x. So this vertex here would be 0, -4. All right, so it can be both. All right, so you wouldn't be doxed, and there's not a question that's this confusing on there. So I just wanted to note that it's actually both forms. And I talked the other day about parent function, y = x² is all 3 forms, which is another amazing thing about the parent function, right? Even its equation fits all the 3 forms. All right. Okay, describe all transformations for each one. All right, so generally work from left to right, but pay attention to detail, especially on how the question's formatted so you can put the right answer into the correct box. All right, so let's look at this one. It's kind of work left to right. So here in front, we have a 1/3, okay? 1/3 is about 0.3. That's between 0 and 1. That's a vertical compression. All right, so I'm gonna find vertical compression. There it is by 1/3, put it there in that box. All right, now we have this -3 inside the parentheses. So if you remember, if it's inside the parentheses here, this needs to change the sign to a +3. All right, so if it's a +3, it's going to the right 3. And we're going to choose right 3 there. Boom. Then outside the parentheses, this -1 is down 1 because it's negative, down 1. Okay, so just a little bit of transformation review. All right, so look at this one. 2 in front, it's bigger than 1. That is a stretch. Boom. All right, again, in the parentheses, +1, change it to a -1. That means it moves left 1 unit. All right, then the 4 outside the parentheses, up 4. All right, and then we're left with the final 2. So remember, the negative in front, that is the reflection on the x-axis. And then 2 inside the parentheses, change it to a +2, which means it goes to the right 2 units. Okay, let's go on next one. Okay, so what helps with these multiple choice questions is a little bit of common sense. The first thing you want to do is notice the a value and what form it's in. So again, parentheses, no squares, so this is the intercept form, so we're going to be looking at roots. But always look at your a value if it's positive or negative. In this case, it's positive, so we're only looking at parabolas that open up. So we can rule out this option here on mine. Okay, so we're basically left with these three options here. All right, and since it's intercept form, okay, this is P, this is Q. Again, they're in parentheses. We got to opposite these numbers, so +1, +5. So we're looking for one that goes through +1 and +5. So this looks like a good one. This one goes through 2 and 6, and this one goes through 0 and 4. Okay, and look at this one that didn't work. Look how it goes through 1 and 5. I'm gonna try to trick you, but it's opening the wrong way. So pay attention, okay, to that there. Okay, a lot of people will choose this, but this is the correct answer here. All right, questions here. All right, pay attention to the a value and what form your quadratic's written in. All right, this one here, parentheses squared, this is in vertex form, which means a vertex. Change the sign here in the parentheses, 1, 12. Okay, so again, we're looking at vertexes. Now notice it's a -3. So we're interested in graphs opening down. So we can rule out this one here. Okay. I don't know if that does anything. Anyway. Okay, so we're looking for a vertex that is 1 and 12. All right, +1 and 12, so that's to the right one. That's 12, that one works. Okay, this is left one of 12, so this one isn't gonna work. But this one's also right one and of 12, so this one could work too. So how do we figure out which one it is? Well, that's a 3. Is a 3 a stretch or compression? So if it's a stretch, which it is, then it should be pulled vertically, which means it has a narrower opening. So it's going to be this one here. Okay, questions on that one? That one's a little tough. All right, so we got a parent function. Okay, they're going to tell us some stuff. It's reflected across the x-axis. It's vertically stretched by a factor of 3. Okay, so again, just right there. Okay, reflect about the x-axis. We're looking for ones that have negatives. So we can already rule out the top and the bottom one, at least in mine. Okay, yours might be scrambled. So here we got these two to look at. All right, vertical stretch of 3, which means it has to have a 3. They both do. Okay, translated to the right, 7 units. Now remember, in the right, that means h is a +7. Okay, so if you're putting in vertex form like it is here, okay, it's not going to stay the same sign, so it's going to be a -7. Okay, because we got to change that h. All right, and that's going to be this option here of the 2. All right, so that's a tricky one. Got to be very careful with the left-right transformations. Okay, which is the graph of this one? Again, another vertex one here, this time -3 and -3. Again, this -3 needs to change signs. Okay, so it's +3, -3. So reflection in the front. So we're looking for parabolas that open down. Okay, so not this one. So we got these 3. It's also moved down 3 units. All right, looks like all of them moved down 3 units. So except this one here. So this is on the x-axis, so this one's out. So we got this one and this one. All right, so then we're going to look at this one shifted to the right. Okay, well, one's to the left, one's to the right. How do I move to the right? So -3 goes +3, so 3 to the right. That's going to be this one. Okay, so again, be very careful with the inside. All right, so it's very similar to our semester exam, guys, that a lot of people missed just because of the h value alone in transformations, guys. So you gotta be very careful about changing the sign. Oh, I think I skipped one. All right, which quadratic function does the graph represent? All right, so they're all in standard form, so we're gonna look at that. So what does standard form give us? Well, it gives us the y-intercept, right? So it looks like this quadratic is gonna intersect the y-intercept. No, we can't quite see it. It probably is a -7. So we can rule out this top one because it definitely isn't +7, which is way up here. All right, so this y-intercept, that one's gone. So we got these 3 to choose from. Okay. The other thing is that it should be opening down. So I can rule out this one here because it's a +x². So these first 2 are gone. We now got a 50-50 chance. All right, so The other thing we can do is look at the axis of symmetry. Okay, in this case, it'll be x equals 3. All right, so if you remember that your axis of symmetry is x equals 2a. However, we can come in here. I'll do that. Did I mess up my preview? Of course I did. What number are we on? 7, 6, 9. Thank you. Did my answers change? Yeah, they scrambled again. All right, so again, this one's out, and then +7's out, so we got these two. So we can use the decimals here. All right, and you know the links in your resource folder, and we can type in an equation from here. So let's try the +6. So -x squared plus 6x minus 7. So let's do that. So -x squared plus 6x minus 7, right? All right, and as you can see, here's the graph here. There's this vertex, okay? Okay, so we're looking for 3 and 2. So going back to our thing here, it is 3 and 2. This looks like it's it. All right, we can check. The other one is the same equation, but one has a -6. Let's see what happens there. So let's change this to minus. And you can see it's on the other side. All right, so it's not going to be this one. So obviously this is on the right side of the y-axis, so it's going to be the +6 version. All right, so use decimals, a very popular tool, a powerful tool that you could use to help you with this test. Okay, identify the features. So this is the bread and butter of the test. And I'll have 3 questions just like this. All right, so first of all, what form is this in? We got a square, no parentheses, standard form. Okay, then it wants to know the A, B, and C values. So what you got to remember with standard form is that you don't have to change any signs at all. So your A value is the first one here, it's the 2, so +2. The B value is the 8, +8. And the C value is 8 also, so +8 again. All right, axis of symmetry. Okay, again, you can type it into decimals, or you can use the formula x equals -b/2a. Okay, whatever it is that you want to do. So, you know, decimals is there, let's type it in there, 2x squared plus 8x plus 8. All right, so let's see, y equals 2x squared plus 8x plus 8. All right, so here's the vertex, and you know your axis of symmetry go through the x value, so it'll be x equals -2. So it's over here. All right, and then the vertex is right there, clicking point, -2, 0. Yeah, there's the answer there. All right, which direction is it opening? When asking direction, which way is it opening? It's opening up. If the parabola is opening up, as you can see here, this vertex is going to be a minimum. It'll be the smallest point on the parabola. So that would be a minimum. All right, domain for all these parabolas, guys, -infinity, +infinity. Nobody should be missing domain on this test. The range changes depending if the parabola moves up and down. Okay, this will move to the left. Okay, parent function is here. Let me just put that parent function in there just so you can see it. X squared, right? So that's where the parent function normally sits. It moves to the left too. All right, however, that's not going to affect the range. Y-axis from bottom to top, it still starts at 0 and opens upwards, so it's going to go from 0 to infinity. That's what I'm going to choose here. So 0 includes 0 to infinity. Okay. X-intercepts, again, look at the decimals. Okay. The vertex is on the x-axis, so there's only one x-intercept. Once a double root, both -2. So we're going to put that x-intercept in there, -2, 0, same as the vertex. Okay. Questions on this, guys? Again, decimals will be a very powerful tool for you to use. All right, a couple more. I think we'll go ahead and just finish this. All right, this one is in intercept form. All right, so we know our x-intercepts already. Okay, that's the power of this one. So A value, again, there's no number in front. It's assumed to be a +1. All right. P and Q, we have to change these signs. So P would be a +1. This Q would be a positive 7, okay? All right, so there is that there. Now it doesn't matter if you choose P to be positive 1 or positive 7. It really doesn't. Technically, both could be right, depending if you switch these around. It's the same equation. That can be confusing here in the review, but on the test, it's not going to be that way. You'll have only one answer for P, and you'll have only one answer for Q. So no sweat that part there. Okay. All right, axis of symmetry. Again, there's an equation, x equals P plus Q over 2, which is 1 plus 7 is 8. Divide that by 2 is going to be 4. So this will be x equals 4. Or, again, graphing on Desmos, x minus 1, x minus 7. Okay, so I'll just go in here, delete this out. X minus 1, parentheses, x minus 7. Okay, real easy. I'm leaving this here. That's my parent function. You can choose if you want that there or not, or you can turn it off. So I want the vertex, which is way over here. Okay, and that's going to be 4, like we said, but negative 9. All right, and going back to here, the vertex will be 4, negative 9. Okay, so how do they get negative 9? Well, you take the 4 and you plug it in. So 4 minus 1 is 3. 4 minus 7 is negative 3. So we got 3 times a negative 3, which is a negative 9. All right, and that's how they got that. Or just use the decimals. All right, the direction, I already forgot. It's opening up again, but you know that from your A value, it's a positive 1, so it's going to open upward. And again, if it opens upward, it's a minimum for your vertex. Domain, all day long. Range, this one changes on us. Look at Desmos. Bottom number here is a negative 9, and it opens up to infinity. So negative 9 to infinity. Okay. X-intercepts, we know that from the formula. Okay. So it's going to be 1, 0, and 7, 0. Again, change these signs, guys. 1, 0, and 7, 0. P and Q are your x-intercepts. Okay. So we got 1, 0, and 7, 0. Guys, please be careful not to mix it up. X-intercepts have zeros for y's, not for x's. So the first number in the order pair is the x. The second number is the 7. Many of you will choose this. Please be careful. Okay. 7, that's my x. 0 is my y. All right. All x-intercepts have 0 for y values. Okay. Again, can't stress that enough. All right. It's such an easy mistake to get points taken off for. All right, guys, last one. All right, good one. Vertex form. So what we started with. All right, again, A here is negative 3. Okay. H, remember we got to change this sign. H will be a positive 1. Okay. K, we don't change at all. Positive 3. All right. So what form is this? Vertex. Axis of symmetry goes through your x-axis of your vertex. Okay. So H and K is my vertex, which means it's 1 and 3. Okay. And the axis of symmetry goes to the x value, which means it's x equals 1. Pretty easy for vertex form. A is negative, which means this one's going to open down. And if it parabola opens down, your vertex is a maximum. Okay, so let's see, a negative 3, x minus 1 plus 3. So negative 3, x minus 1, square this, and then we got plus 3, I think. Shift my graph a little bit. Okay, so again, parent function, and boom, there's my vertex. 1, 3, opening down. That makes it a maximum. It's going to be the highest point in that parabola there. Okay, so there it is. Domain, again, all day long. Now the range, it's going to be different. So be very careful. It's bottom to top. So here, this parabola opens downwards, which means we're going to come up from negative infinity all the way up to a max of 3. Okay, negative infinity to 3. All right, so there's a negative infinity to 3. All right, so again, we'll try to trick you. This is from 3 and up. This parabola doesn't open up, it opens downward. So negative infinity to 3. Okay, x-intercepts, again, use Desmos. So we got 1 at the origin. We got another one here at T0. So 0, 0, 2, 0. Boom. Okay, again, guys, please don't mix up the numbers. Transformations from left to right. All right, so since vertex form is transformation form, so the first thing we have is a negative. That means it's a reflect about the x-axis. And we look at the number, which is a 3. It's bigger than 1, so it's a vertical stretch. Then you're going to look at x minus 1, which means h is a positive 1, which means it goes to the right one. All right, and then you got this last one, k, which is 3, which means it's going to be up 3. Okay, last thing is the standard form. It did not ask for the y-intercept. Your test will. Okay, guys, so the y-intercept, guys, what is it? Right here, 8, 0. I mean 0, 8. Okay, so be very careful with that. I should have a y-intercept in here. All right, so that Woolley test will ask you that in standard form. It's really easy. It's this last number. Okay, y-intercepts have a 0 for the x-axis, so any point on the y-axis has a 0 for the x bar. So it's going to be 0, 8 for your y-axis. Okay, so it is on your homework though. So again, just because it was missed on the review, still on your homework. It's covered. I'm telling you right now, it's on the test. So know that standard form gives you the y-intercept. All right, let's go over the strengths real quick. So standard form gives you the y-intercept. All right, going over here, intercept form gives you the x-intercepts. Okay. And then vertex form is probably the most useful, gives us the vertex, okay, and is in transformation form. Alrighty, guys. Any questions over any of that? Okay, there we go. Okay, guys, so get busy with the review, finish it, and then your homeworks, and we will test tomorrow, and I'll be here for questions, guys.